Okay, graphing an exponential function. When I think of exponential functions, I think of that $10,000 CD my grandma gave me when I was first born. I wish that made so we had $10,000 given to us when we were first born, and we can't touch it. They said that's for you for later in your life, and so in other words, it's 10,000 bucks. It's been sitting in a bank in a CD at 3% interest, compounded quarterly, and we just want to know what that's looked like. How has it been growing over the years? And so, this isn't a video on how to set this equation up, but maybe you'll learn something. Um, so if you were $10,000 at 1 plus your rate of growth is 0.03, divided by the number of compounds, which is 4, all to the 4t power. And I'm off just a little bit. And so what you have there is 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 a function. So we'll put this in function notation and look at it. Now I'm not going to graph them by hand, but I could, and I'm going to leave it in. And you could simplify it a little bit, but I'm going to plug it in like this, just so you can kind of see what it looks like. And so here we go. So there's Geogebra. I'll go ahead and plug that in. So f at x equals 10,000 times 1 plus 0.03 divided by 4 to the 4x power. And we'll plot that, and it probably doesn't even register on our graph. And so we'll find that thing. And I know 10,000 is our initial value, so we've got to have at least 10,000 showing. Oh, there it is. It's appearing. And on the bottom, x represents years, so here's 6 years. It looks kind of linear. But we'll drag that thing in to maybe look at a lifetime's worth of data. Whoops. So there we go. So by the time I'm 40 years old, if I got this when I was born, I'll swing it up here to 40. You can kind of see how it grows, and it still doesn't look very exponential. So when I was 38 years old, the thing's worth $31,449, which is my age currently. Well, I guess I'm 39. Probably 0.04 is pretty close. So at 39 years, right now that $10,000 that Grandma gave me has tripled, and so that shows you. And you can kind of drag it back and forth and see. When you're 10 years old, it was worth $13,000. 3% is not a whole lot of interest, but at least it's growing, probably about the rate of inflation. And so that's what you can do with an exponential function. But you're not going to have to work with anything that complex. And if you do, we've got all these nice tools nowadays to show what's happening graphically very quickly. Most of the graph functions you're going to graph would be something like this. So let's say it's just f at x equals 3/4 to the x power. So when you graph these, the main thing you're going to do is just make a table. It's just like anything. When you don't know what's going on, if you don't know any special tricks, you just start making a table and you just pick values. So I'm going to pick maybe, I don't know, -3, -4. Oops, let's do this thing in order. So -3, -2, -1, 0, 1, 2, and 3. And just start plugging it in so that we can just get kind of a rough sketch of this thing. So 3/4 to the to the negative third power is basically would be the first one. So I'll just kind of show you what I'm typing in. I'm going 3/4 caret negative 4. And 3/4 negative 4. Been a while since I've used this calculator. Trying to figure out what's where. Okay. And so that's about 3.16. You know, and I'm just going to rough sketch this thing. And so you do the same thing to the negative 2 power. And that's 1.78. And then you do the same thing to the negative 1 power. Oops. And I already messed up, but that's 1.3. This was to the negative 4th power. I guess I could change it. Negative 4 was 3.16. I don't know where the negative 4 came from. And then 3/4 to the 0 power. That one's kind of nice. That's 1. 3/4 to the 1 power is 3/4. 3/4 to the second power is 3/4 second power would be 9/16, which that is 0.56. So about 0.6. This is about 0.7. This is 7.75. To the third power, so 3/4 to the third power is 0.42, and we can kind of see a trend starting to develop here. And then, so we'll just graph those values. I'll use this one. It doesn't have to be anything real fancy. So negative 4 is 3.16. So there's negative 4, 3.16, 2, 3. Looks like that. About. Negative 2 is 1.78. It would be somewhere in this vicinity. Kind of rough. Negative 1 and 1.3. Somewhere right there. 0 and 1. 1 and 3/4. And remember 2 is a little over 0.5 and then a little under 0.5. And so we've got a function that's starting to look like this. And here's what's kind of neat about these, and which seems kind of strange, but there's an asymptote right here at the x-axis on this one. So it will never ever reach the x-axis. However, you would think it looks like we're going to have an asymptote in this vicinity, but that's not true. You will keep going forever in a negative direction and always get a bigger number. You know, you could plug in, you know, you think about the equation, 3/4, and you plug that into the negative 100th power. If you do positive 100, you're going to get just about 0, but not quite. 3/4 to the negative 100 power, well, that would be 4/3 to the 100 power if you use your negative exponents. And so 4/3, 4/3 to the 100th power is 3 times 10 to the 12th. So it gets big rapidly going in the negative direction, which that's what exponentials do. But you'll always get a bigger number, and you can go as far left as you want to go. So there is no asymptote. It's just growing so fast in that vertical direction that it looks like there's an asymptote there. So anyway, it does have a horizontal asymptote, but no vertical. And best of luck. I hope this helps. And that's generally how I graph these. I just make a chart and start going to town. It's real nice when you can use Geogebra. I just love that. I love that tool. Use it every day in every aspect of the math that I do. And I encourage you to do the same. You know, check your, do a few of these by hand. Make sure you can do it, and then check them in Geogebra. See what you're coming up with, because eventually you're going to be able to do fun problems like this one. I guarantee you that's fun to watch your money grow. It's not so funny when you borrow it, but when you're loaning it, when you got some money in the bank and it's growing, it's fun to watch it grow. And this graph You could just follow this point A as far as you wanted to go. Maybe you want to keep that in the bank forever past your 40s. So when I'm 45, that account will be $38,000. It will have more than tripled, almost quadrupled. So thanks for listening. Good luck. Exponentials are what make the world go round. So see you next time.